Hello students, this is Umer Ahmed. Today we'll learn the chapter Polynomials, which is chapter number 2. Okay, we get into the deep introduction of this chapter, Polynomials. What is meant by polynomials? Okay, before entering to what is meant by polynomials, I'll have a basic questions which you have learned in 9th grade. Okay, you might have learned what is meant by variable. Correct? You might have heard this name variable. Okay, and you might have heard the name constant also. Constant. Okay, what is mean by variable? The word itself says something variable, varies. Correct? Something which is changing, variable is a symbol which can be changed. Okay, based on anything. It can be a symbol. It is represented by any alphabet x, y, z, x, t, etc. Okay, take an example. I'll clear this with an example. Assume we'll take x plus 5. In this x plus 5, x is a variable. Which is a symbol, and it can be changed. It can be variable. X can be anything. X can be either 2, either 1, either 0, either 1, either 5, anything. Okay, anything. Now the 5, what is here? Okay, 5 is nothing but constant. This 5 is constant. Okay, constant can be any number, either 5, 6, 7, 8, 100, 10. Okay, 10, anything. X is variable, 5 what is here is constant. Hope this is clear what is variable and a constant. कांस्टेंट कोई भी नंबर हो सकता है, 1, 2, 3, जहां सब जगह वही नंबर बुलाया जाएगा. 5, 7, 8 जो भी नंबर हम डाल सके उसको कांस्टेंट कहते हैं. एक्स ऐसा वेरिएबल है, एक्स ऐसा सिंबल है जो वेरी हो सकता है. ओके, होप दिस इज क्लियर. विद द हेल्प ऑफ दिस विल बी मेकिंग अ टर्म. विद द हेल्प ऑफ दिस विल मेकिंग अ टर्म. ओके, विद द हेल्प ऑफ कांस्टेंट एंड वेरिएबल और कांस्टेंट के जरिए एक टर्म बना सकते हैं. मान लीजिए 5x, ये पूरा एक बन गया टर्म, इसको बोलेंगे टर्म. ओके, टेक एन एग्जांपल. 5x plus 3. x ये वेरिएबल है, x एक वेरिएबल है. 5 इसको जो चिपक के जो बैठा है, x के जो बाजू चिपक के जो बैठा है, the number which is just close is next to variable is called coefficient. You have heard this, coefficient. Correct? Coefficient. 5 is coefficient. Together this whole thing with number and the variable, the coefficient and the variable is called term. You might have this. There is one term here, there is one term here. Okay, this is two terms. Okay, say an example again. If I give the example 3x plus 7, here is one term, here is one term. Okay, again this is two terms. Similar to this. Based on these terms, the polynomial is classified into three terms: monomial, binomial, trinomial. Mono, bino, trinomial. You might have heard this in 9th grade. Okay, quickly we'll revise that. After that, types of polynomials will be seen, and what is mean by the polynomial, that is also will be seen. Okay, let me clean it all of this. Now we'll come to what is mean by what is polynomial. What is mean by a polynomial? What is polynomial? Okay. In this, a polynomial is an algebraic expression. A polynomial is an algebraic expression. What is mean by algebraic expression? Algebraic expression का मतलब क्या है? मतलब मान लो अगर टर्म्स को सेपरेट करेंगे सेपरेट करेंगे प्लस और माइनस से, टर्म्स को सेपरेट करेंगे प्लस और माइनस को, उसे कहते हैं algebraic expression. Any expression which is separated with the help of plus and minus is called an algebraic expression. मान लीजिए एक एग्जांपल ले लेंगे 3x² plus 5x plus 2. ओके, एक algebraic expression है, हाँ, ये एक टर्म हुआ, दूसरा टर्म है, ये एक टर्म हुआ, तीसरा टर्म है, ठीक है, 1 2 3 टर्म्स है, 3 टर्म्स, and it is separated by plus. It can also be separated by minus also. Clear? 3 terms separated with the help of plus and minus is called algebraic expression, which is not equal to, one condition is there, which should not be equal to 0. अगर मान लो 3x² plus 5x minus 2 को मैं अगर इक्वल टू 0 किया तो ये algebraic expression नहीं हुआ, ये algebraic expression नहीं हुआ, इसको बोला जाएगा equation. Correct? Let me not go detailed into this things. Hope it is clear what is meant by algebraic expression. Algebraic expression are the expressions where it can be the terms are separated with the help of plus and minus. Clear? Now come to the topic of polynomial. A polynomial is an algebraic expression. A polynomial is an algebraic expression which is made of constants and variable, where the whole power is, where the variable power is whole number. This is very important. The variable power to be whole number. Take an example. If I take example 3x², same example, plus 5x plus 2. Is this a polynomial? Yes. The power for the variable is 2. Or we tell the degree of a variable. The degree of a variable is 2. Okay. 2 is a whole number. I can tell this is a polynomial. Take an example. X minus x power 1 by 2 plus 3. Is this a polynomial? No. It is not a polynomial because the power is fraction. The power neither it should be a fraction, neither it should be a negative, neither it should be any number which is, it should always be a whole number. उसका पावर जो है होल नंबर ही चाहिए. अगर इसका पावर 1 by 2 है तो इसे कहते हैं, इसको पॉलिनोमियल नहीं कहा जाता. टेक एन एग्जांपल 2 root x plus 5. Is this a polynomial? No. How? 2 root can be written as x power 1 by 2, correct, plus 5, but 1 by 2 is not a whole number, hence it is not a polynomial. Hope it is clear. A polynomial is an algebraic expression made of constants and variables, okay, where the variable power should be whole number, okay. Repeat with me. A polynomial is an algebraic expression made of constants and variables. A polynomial is an algebraic expression made of constants and variables where the variable power is whole number. Hope it is clear. Based on this, okay, the types of polynomials we'll be quickly learning. What is the types of polynomial? I don't want to go more into this. Types of polynomials, we will learn the types of polynomial. Then quickly we'll go to the exercise. Clear? We'll get into the types of polynomials. In this, we got in terms of number of terms. Already we have learned this. Quickly I'll revise this. Then types of polynomials. What are the types of polynomials? Okay. See, number of terms we already learned. Just now I discussed with you. Monomial. One is monomial. Correct. then second is binomial, then trinomial, correct? So mono, the word mono itself says one single term. Take an example, 5x. This is a monomial. Or you can take 3x, monomial. Then 2, monomial. These all are monomials. Binomial, two terms, correct? Two terms is called binomial. Take an example, 5x plus 2. 5x is one term, 2 is one term. Clear? Binomial. Then try add one more thing, 5x square plus 3x plus 1. This is trinomial. Okay, three terms. Clear? Now here I'll write three terms. Now quickly we'll go ahead with types of polynomials. The first one I'll come with linear polynomial. See, the general form of this linear polynomial is ax square plus ax plus b, not ax square, ax plus b, and here a should not equals to 0. Take an example, a is constant, I'll take 5, or anything 2x plus 5. If a is not equal to 0, meaning if this is 0, we can't tell it is a linear. This everything will become 0. We remain with only the constant. So it is not a linear. That's the meaning of a is not equal to 0. अगर a को ही अगर हम 0 बना देंगे तो ये पूरा टर्म 0 हो जाएगा, मतलब रहा हमारे पास 5 जो है कांस्टेंट है, इसीलिए हम कंडीशन लिखें a is not equal to 0. And what is highest degree, highest power or highest degree for this? Highest degree is 1. Linear polynomial is a polynomial where the highest power or degree is 1. General form of a linear polynomial is ax plus b. The example 2x plus b where a is not equal to 0. Clear with the linear polynomial? Linear polynomial is done. Then we'll come to quadratic polynomial. So quadratic, your chapter deal with more about the quadratic polynomial itself. Quad meaning 2, correct? The general form for this is ax square plus bx plus c. Again the condition a is not equals to 0. Take an example, 5x square plus 2x plus 3. Okay, here the highest power, quad is meaning 2. The highest degree or power. Degree is nothing but power. It is one and the same. So highest degree is 2. Clear? Linear, quadratic polynomial, the polynomial where the highest power is 2. General form of a quadratic polynomial is ax square plus bx plus c, where a is not equal to 0. Then we'll come to cubic polynomial. What is meant by cubic polynomial? It's the same story what we have written, just the general form changes. The highest power, the cubic degree to be 3. The highest degree of a cubic polynomial is 3. Okay, general form of this, same thing, ax cube plus bx square plus cx plus d. D is a constant, is equal to 0. Is equal to 0, no? Where a is not equals to 0. Example, 3x cube plus 2x square plus 5x plus 4. Okay, this is a cubic polynomial. The highest degree, cubic polynomial is a polynomial with highest degree is 3. Clear? Then we'll come to the next polynomial, which is biquadratic. Bi meaning 2, quad मतलब 2, biquadratic मतलब इसका पावर कितना है? Highest power is 4. Highest power is 4. What is general form? Same story. Can you try to tell with the help of this itself? The highest power is ax power 4 plus bx power 3 plus cx power 2 plus dx plus e. Okay. Or in a simplified not equals to 0. Okay. In a simplified manner, we can also write it as ax power 4 plus bx plus c is equals to, ax power 4 plus bx plus c. Don't put is equals to 0, it will become an equation. The general form of biquadratic polynomial ax power 4 plus bx plus c. Ax power 4 plus bx plus c. Where the highest power is 4. Where the highest power is 4. The based of types of polynomial, we learned linear polynomial, we learned quadratic polynomial, we learned cubic polynomial, we learned biquadratic polynomial. Okay, clear. Now we'll come to constant polynomials. Constant polynomial. What is meant by constant? We know the term constant 5, any number 3, correct? Now this is a constant polynomial. What is the degree of this? Question. The question comes. The degree of a constant polynomial is 0. Okay. The degree of a constant polynomial is 0. Anything x, right here, x power 0, 5x power 0, anything power 0 is 1, correct? Anything x power 0 is 1, anything power 0 is 1. We know this. Okay. 5x power 0 is 1, so the degree of this is 0. Then finally we will come to the concept zeros polynomial. Okay. Zero polynomial is nothing but 0 itself, correct? What is the degree for this? This is an important concept. Okay. What is the degree of a zeros polynomial? The degree of zeros polynomial is not defined. How? See, if I put variable x, okay, variable x, it can be 1 also. If I put variable x, it can be 2 also. If I put variable 10, it can be anything. The power can be anything. So it is not defined. I don't know anything. उसका पता ही नहीं क्या मिलेगा वैल्यू इसका. So the zeros of a polynomial whose degree is 0. Whose degree is not defined. With the help of this example, you can identify it. Okay. Hope this is clear. All the concept is clear. Based on the number of terms, we have monomial, mono, bino, and trinomials. Based on the types of polynomials, we got linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, and we have constant polynomial and zeros polynomial. Okay, clear. Next, we'll go to the exercise. Just now we discussed zeros of polynomial. It is not zeros, it is only 0 of polynomial. Okay, meaning the 0 of polynomial where the degree is not defined, which I told you. Meaning if you put the variable x, if you put 1, we don't know what is the value. Okay, we are not defined. If the 0 of a polynomial whose degree it can be 10 also, whose degree it can be 100 also. Hence we tell that the degree is not defined. Okay, this is a 0 of a polynomial. I just told zeros. Sorry for that. It is not zeros, it is 0. Okay, it is 0. Now we actually come to the concept. What is the zeros of polynomial? Zeros of polynomial. We know that the polynomial is represented in the form of p of x. X can vary. Obviously, it's a variable. Correct? Assume the polynomial is x minus 3. x की एक ऐसी जगह एक ऐसा नंबर बताओ जिससे कि ये पॉलिनोमियल 0 हो जाए. x को अगर मानेंगे हम 3, so this p of x की वैल्यू हम 3 रखेंगे, तो 3 minus 3 is 0. Okay, 3 minus 3 is 0. Okay, clear. zeros of polynomial, any number in a polynomial, what to be substitute to get the zeros of the polynomial, to get the zero of the polynomial. For example, if you substitute 0 in place of x, if you substitute 0, this expression, this algebraic expression, this polynomial is becoming 0. Okay, hope it is clear. Hope this is clear. Hence, the zeros of the polynomial. What is the zeros of the polynomial here? Zeros of the polynomial is 3. Let us understand the geometrical meaning of the polynomial with the help of this graph. Okay, if you see carefully, this graph, we have this x-axis, this is x-axis, and this is y-axis. Correct? Zeros, geometrical meaning of polynomial. Okay, what are the number of zeros here? Number of zeros. And what are those zeros? Okay, what are those zeros? नंबर ऑफ जीरोस कैसे पहचाना जाएगा? जहां जहां एक्स एक्सिस में जहां जहां एक ग्राफ कट हो रहा है, यहां पे 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 कट हो रहा है. नंबर ऑफ जीरोस आर 4. 1 2 3 4. नंबर ऑफ जीरोस आर 4. Okay, what are those zeros? At what places in the x-axis it is cutting? -3, -1, here 1, and here it is 3. Here it is 3. What are the zeros? -3, -1, 1, and 3. The number of zeros is 4, which is 1, 2, 3, 4. And the zeros are minus x-axis में. X, this is x, this is y. This is x, this is y. X coordinates जो भी हैं हमारे, उसको zeros इसको बोलेंगे. ठीक है, वो पॉलिनोमियल का p of x जो भी है उसके जीरोस हैं. और नंबर ऑफ जीरोस कितने हैं? 4. ये वैल्यू, दिस वैल्यू इफ यू सब्स्टिट्यूट इन द पॉलिनोमियल व्हाटएवर इट इज, quadratic polynomial or cubic polynomial, you will get the number of zeros are 4. Number of zeros is 4. Just keep in mind, number of cuts 1 2 3, number of cuts whatever you can see in x-axis, those number of zeros are 4. Simple. We'll go to the next exercise. Okay, hope the concept is clear. We'll come to the exercise 2.0. The first one is find the number of zeros. If you see this very first question, okay, this is x-axis, okay, which I have written here, and this is a line which they have given. Okay, this line is getting intersect at y-axis, not at x-axis. We already discussed to find the number of zeros of polynomial, the graph should intersect at x-axis. Correct? The graph should intersect at x-axis, but here it is getting intersected at y-axis. So there is no, what it can write, there is no number of zeros is, there is no zeros of polynomial. Therefore number of zeros is 0. Okay, here if you see carefully, in the x-axis it is getting cut here at this point. So therefore number of zeros are is equals to 1. Okay, number of zeros is equals to 1. If you see this, the third question, here is 1, here is 1, here is 1. So number of zeros are 3. If you see here, this is x-axis, correct? This is x-axis, but it is in negative. Don't think that it is in negative, but the zeros of polynomial we have to see only positive. Both positive and negative we have to consider. So here is a point, here is a point. So number of zeros here is 2. Okay, here the number of zeros 1 2 3 4. Number of zeros are 4. Okay, here where can we feel, where is this touching? 1 2, and here is 3 in x-axis. So number of zeros is 3. This is your exercise 2.1, which is very simple. Next we'll go to the 2.2. okay, exercise, and we'll start with the 2.2. Now we're gonna study exercise 2.2. Exercise 2.2. Before going to this exercise, We'll quickly see the formulas what is related to this exercise, and we'll go to the exercise. Okay, relationship between zeros and a coefficient of polynomial. Relationship between zeros and coefficient of polynomial. To see, this is a big heading. Let me clarify this. Assume the quadratic equation 3x square plus 4x plus 5. Okay, not the quadratic equation. Assume this is an expression. Okay, not the quadratic equation. This is an expression, correct? Algebraic expression. What we have learned in exercise 1.1, 2.1, correct? 3x square plus 4x plus 5. In this, if we solve this quadratic equation, we will be getting two roots, correct? Two roots. Roots or either zeros also you call. Okay, two roots we will be getting. So we will assume the two roots are alpha and beta. Alpha and beta, correct? If you solve this algebraic expression, we will be getting two roots. The name of the roots I am giving as alpha and beta. Alpha and beta. Okay. With the help of these roots, okay, they have given one formula, sum of the roots. Sum of the roots. Okay, what are the sum of the roots? If these two roots, alpha plus beta, if we add, is equals to minus b by a, is equal to minus b by a. Okay, or you can tell minus of coefficient of b divided by coefficient of x divided by coefficient of x square. Coefficient of x square. This is a formula you can remember. Coefficient of x divided by coefficient of x square. See, these two zeros what I am getting, it will be equal to the, from here if you see what is a is 3 and b is 4 and c is 5, correct? That will be equal to this. What is b? Minus 4. What is a? 3. If you solve this quadratic, this is an example. This is just an example I am giving. If you solve this quadratic equation, you will be getting two roots which will be equal to this. Okay, hope this is clear. This is very important formula which you will be gonna learn. Okay, very important. Sum of the roots. Now, if you come to product of the roots, it is similar to this. Alpha beta is equals to c by a. Alpha beta is equals to c by a, equals to constant term divided by coefficient of x square. The product of the two roots, what will be getting? The product of the two roots is equals to c by a, meaning 5 divided by 3. 5 divided by. Hope this is clear. Repeat with me. Sum of the roots is equals to alpha plus beta is equals to minus b by a. Sum of the roots is equals to alpha plus beta is equals to minus b by a. Product of the roots is equals to alpha beta is equals to c by a. Wherein constant term, this constant term divided by coefficient of x square. Coefficient of x square, that is 3. Clear? This is very important both. Before, if we know this both, then we can easily solve exercise 2.2. Okay. Now, before entering to this, one more thing. Assume if they give the value of alpha and beta, two zeros, what we'll be calling two zeros. Okay, two zeros. Now, hope this is both clear, correct? Relationship between the zeros. What is the relationship between the zeros and the coefficient of this? What are the coefficient of this? Is that coefficient of the polynomial? That is the relation between these two. Okay. Now, if they give, assume the alpha has been given 1 and beta has been given 4. Alpha 1 and beta 1. And they are telling to find the polynomial. In that case, we will be using the formula k into x square minus sx plus p. S square minus sx plus p. Okay, where s stands for sum of the roots. Okay, and the p stands for product of the roots. Clear? Sum of the roots and product of the roots. So we have to substitute the given values in this formula, in this quadratic polynomial, okay, to find the polynomial. Hope this is clear. This 2 is very important. These 3 formulas are very important to find all of the questions of exercise 2.2. Quickly we'll revise it again. Alpha plus beta is equals to minus b by a. Alpha plus beta is equals to minus b by a. Alpha beta is equals to c by a. If the zeros is been given, if two zeros are given and they need to find the quadratic polynomial, then the formula k into, where k is a constant, k into x square minus sx plus b, x square minus sx plus b. Clear? Quickly we'll move to exercise. Next we'll come to the exercise 2.2. Find the zeros of quadratic polynomial and verify the relation between the zeros and the coefficient. Okay. First you will get the zeros of the polynomial. Okay. Then we will verify this. Okay. Step by step we will be solving by splitting method. See, the question is x square minus 2x minus 8. For this algebraic expression, we'll solve it using the splitting method, or also we call factorization method. Okay. See, the question is x square minus 2x minus 8. We need to split this. Okay. How to get the zeros? See, nothing is there in the coefficient 1. You know it, correct? We need to multiply the coefficient and the constant term. Okay. Multiply coefficient and constant term. So what is 1 into 8? 1 into 8 is 8. Correct? Assume it was 2 here. So 2 into 8 is 16. Correct? We would have multiplied like that. So nothing is there 1. So we took 1 into 8 is 8. Now we need to choose two numbers. If we multiply the two numbers, we need to get 8. If we add and subtract, we need to get 2. Okay? How? See, first of all, see 8, which table it goes. 2 4s are 8, correct? 4 2s are 8, correct? And 8 1s are 8, correct? Any other table it will go? No. 2 4s are 8. If you multiply, I'm getting 8, correct? If you add or subtract, I'm getting 2. No. 2 minus 4, I'll be getting minus 2, correct? 4 2. 4 2s are 8. If you multiply 4 and 2, I'm getting 8, correct? If we subtract 4 minus 2, I'm getting 2. Yes, this is working. I'm getting the middle term. Okay. 4 2s are 8. 4 and 2. Is it clear? Let me repeat it again. Multiply the coefficient and the constant term. 1 into 8 is 8. I have to choose two numbers. Such that if you multiply these two numbers, I need to get 8. If you add or subtract, I need to get the middle term. Clear? 4 2s are 8. Whatever the minus sign is there, put it over here. What we are doing? Subtracting. Correct? What is minus plus? Subtract. Minus into plus, minus. This is the case where the students get little confusion. Okay? Whatever the minus is there, write it over here. Think the multiplication sign, minus into plus is minus, correct? Plus into minus is also minus. Plus into plus is plus. Minus into minus is plus. This is a basic. See, I'm teaching you very clearly so that you understand this problem. Minus into plus is minus, correct? Minus, we are doing the subtraction. What to put the sign? Minus and plus. Minus into plus, minus. Minus 4 plus 2, I'll be getting 2. Okay, whatever the x is there, add it over here. X and x. Now, see carefully. X square minus 4x plus 2x minus 8. Now pair it. These two and these two. What is common in this both? X and x is common. X is removed. How many x is removed? 1 x is remaining. So x I took out, minus 4. Minus 4. What is common in this both? 2 table is common. What is remaining? Only x is remaining. 2 4s is 8. 2 4s is 8. Clear? So you need to decide what symbol you need to put. Either you have to put addition or subtraction. So to sing that, if you put minus into plus, minus, no. If you put plus into plus, plus into minus, minus. If you multiply and open the bracket, you need to get back this. Okay, plus into plus 2x, plus into minus, 2 4s are 8. I'm getting back this. In such a way, you need to put the sign. Clear? Now, These both are same. I'll write it once. X minus 4 and x plus 2. X plus 2. X plus 2. So what is the zeros? What is the two roots? X is equals to 4. X is equals to minus 2. X is equals to 4 and x is equals to minus 2. Therefore, the zeros are 4 comma minus 2. Clear? 4 comma minus 2. Now he's telling to verify the relationship between these two. So obviously we just read the introduction, the relationship between these two. Quickly we will verify this. Sum of the roots is equals to alpha plus beta is equals to minus b by a. Okay, alpha plus beta is equals to minus b by a. From this, what is a? A value 1. What is b? Minus 2. Be careful, minus 2. C value minus 8. Clear? 1, minus 2 and minus 3. What is the roots I got? 4. Alpha I got. This I'll consider this as alpha and this I'll consider this as beta. What are the zeros I got? 4 plus of minus 2. This is what the one more 0 beta I got. Clear? So what is minus b? What is b here? Minus of minus 2 divided by a value is 1. 4 plus into minus 2 is equals to minus into minus plus 2. 4 minus 2 is 2. 2 is equals to 2. Hence it is verified. Hence the relationship is verified. Okay. So try to understand. Verify the relationship between the zeros. This is the zeros I got. Okay. The relationship formula is what? Alpha plus beta is equals to alpha plus beta is equals to minus b by alpha plus beta is equals to minus b by. Substitute in that relation between the zeros and the coefficient. What are the coefficient? This is the coefficient, correct? We are substituting the coefficient of that with the help of that formula. We are getting LHS is equals to RHS. Okay. You can conclude this. LHS is equals to RHS. Now, product of roots is equals to alpha beta is equals to C by A. Alpha beta is equals to C by A. What is C here? What is C here? According to us, alpha beta is 4 and beta is minus 2 is equals to what is C? What is C? C is minus 8 upon A is 1. Clear? 4 2s are 8. Minus 8 is equals to minus 8 is equals to minus 8. Therefore, LHS is equals to RHS. This problem, I explained you very neatly. Okay. If you have any doubt, please let me know in the comment section. We'll come to the next question. 4s square minus 4s plus 3. Before getting into this question, you have to check whether this question is in a general form, which is ax square plus bx plus c. Correct? A, b and c. We got a, b and c. Correct? So x square, s and constant term. Clear? Okay. This is verified. That's the first step we need to verify. Then I told you obviously multiply the coefficient of x square and constant term. 4 into 1 is 4. Clear? 4 into 1 is 4. For this 4, I have to think two numbers, wherein if I multiply the two numbers, I need to get 4. If I add or subtract, I need to get the middle term. Correct? So what's that number? If I add or subtract? In which table 4 goes? 2 into 2, 4. Correct? 4 into 1, 4. Then any other tables? No. 2 2s are 4. Correct? I am getting 4. But 2 plus 2 I am getting 4. Then 2 2s are 4. If I add 2 plus 2 I am getting the middle term. Clear? What I told to write this minus sign over here. Okay. What we are doing? We are adding it. Minus into minus is plus. Minus 2 is minus 4. That's what we need to do. Okay. So what I told, add this, whatever the coefficient of b is there, x, whatever they have given the variable for the coefficient of 4, we need to add it here. Minus 2s. Clear? Now 4s square minus 2s minus 2s plus 1. What I told? Pair it. Pair these two. What is common in this? 2 is common and s is also common. Clear? If I remove 2, I remain with 2. S is removed, I remain with s. Minus 2s is common, I remain with only 1. Clear? Now, whatever you wrote it over here, write the same thing over here. 2s minus 1. Or you can think that minus 1 you are taking common out. Minus 1 from this, you are taking common out. So now just cross check. Minus into plus, minus, minus into minus, plus. Clear? Either you can remember that whatever you wrote here, you can write it as it is and just check which sign you need to put. Without, if you put 1 also it's okay, if you don't put also it's okay. Anything you can learn it. Okay, now hope this is clear. Let me tell once again. After you get this, whatever you write it here, same thing you write it over here. Just think what sign you need to put. Check here. If you put plus into plus, correct, but you are getting minus here, so you need to put minus into plus, minus into minus, plus. Clear? See, this is very clearly I'm explaining, very deeply I'm explaining this concept. Most of the people who teach in YouTube, they'll explain very quickly. Okay, so I'm teaching very slowly so that you can get it what exactly and how to solve. It is very important for your further problems also in coming chapters. Okay, in this both common is 2s minus 1, and here if you see this and this, 2s minus 1. Okay, 2s minus 1 and 2s minus 1. So 2s is equals to 1, 2s is equals to 1, s is equals to 1 by 2, s is equals to 1 by. So this are the zeros of the polynomial. These are the zeros of the polynomial. Clear? Now we'll come to the verification part. So what are sum of the roots? Sum of the roots is equals to minus b by a, or you can write alpha plus beta is equals to minus b by a. What is alpha plus beta? 1 by 2 plus 1 by 2 is equals to, what is minus, what is b here? 4, minus 4, correct? Minus of minus 4 upon a is 4. A is 4. If you solve this, 2 and 2 LCM is 2, correct? 1 plus 1 is equals to 4 upon 4. 1 plus 1, 2. 2 upon 2 is equals to 4. 4 upon 4, if you cancel, you will be getting 1. 2 and 2 get cancelled, 1 is equals to 1. 1 is equals to, which is LHS is equals to RHS. LHS is equals to RHS. Clear? Hope this is clear. Now, you can mention here sum of the roots. Okay, now the product of the roots, okay, alpha beta is equals to c by a, or also you can write that formula, that is constant term divided by coefficient of x square. Constant term divided by coefficient of x square. Here we are taking s here, so coefficient of s square. Clear? What is alpha? 1 by 2 into 1 by 2 is equals to, what is c here? According to us, 1 upon, what is a? 4. So 1 1s are 1, 2 2s are 4 is equals to 1 by 4. Clear? 1 by 4 is equals to 1 by 4. LHS is equals to RHS. Hope this question is clear. Quickly, we'll get back to this question. Okay, how to split this? I told you the first step is to check whether it is in general form. So this is not in general form. Ax square plus bx plus c, which I have wrote here, ax square plus bx plus c. This is not in the general form. I just need to rearrange it. 6x square minus 7x minus 3. Okay, by factorization method, or splitting the middle term method. 6x square minus 7x minus 3. Clear? 6x square minus 7x minus 3. Let me clear this so that you'll understand here very clearly. What did I get? 6x square minus 7x minus 3. Correct? So you need to multiply this coefficient of x square and the constant term. 6 into 3 is 18. Correct? I need to split 18. I need to get the two numbers. If you multiply the two numbers, I need to get 18. If I add or subtract, I need to get the 7. Before getting into that, tell me 18 goes in which tables? 18 getting 6 3s are 18, correct? Then 4 how much are? 4 4s are 16. No. 2 table 2 9s are 18, correct? 9 2s are 18. Any other table? 7? No. 8? No. 9 10 6 5? No. 4 3 6 are 18, correct? Then 18 ones are 18. In these all tables it will go. Clear? In these all tables, this is multiplying, correct? Now 6 3s are 18. It is getting multiplied, but if I add and subtract 6 plus 3, 7 8 9. No, I'm not getting the middle term 7. I need to get 7 as in middle term, correct? 7 as in middle term. If I subtract, I'll not get. If I add, I'll not get. No. 2 9s are 18. 9 minus 2 is 7. Yes, I'm getting, correct? But we will not take this. We will take this, the bigger number first. 9 2s are 18. 9 minus 2, I'm getting 7. Clear? We'll write the two numbers 9 9 2. 9 9 2. 9 2s are 18. 9 2s are 18. If I subtract 9 minus 2, I have to get 7. After subtract 9 minus 2, I'm getting 7. Clear? So what is the sign here? Minus, correct? What I am doing with this? Subtracting, correct? Minus into plus is minus. Minus into plus is minus. I told you already. I explained you all those concepts in question number 1. Clear? Whatever the variable is there, write it x and x. Now help me out. 6x square minus 9x plus 2x minus 3. What is common in this? 3 table, correct? 3 table 2 3 2s are 6. 3 2s are 6. X is also common, correct? 3 and x is common. I'll write one remaining x. Clear? 3 3s are 9. 3 3s are 9. 3 is common out. 3 3s are 9. See why I'm explaining very slowly. The students who are very dull in this, so that they can understand it clearly. That's why I'm explaining step by step. 3 3s are 9. X is out. So I told you whatever we write here, same thing you write it over here. So what sign you need to write? Minus 1 is common. Minus 1 is common. Or minus. Minus into plus. Minus. No. Plus sign is common. Plus into plus. Plus. Plus into minus. Minus. Clear? Is it clear? Nothing is there. 1. 3x plus 1. 3x plus 1. 2x minus 3. 2x minus 3. 3x is equals to minus 1. 2x is equals to 3. X is equals to minus 1 by 3. This is one of the zeros of the polynomial. Other is x is equals to 3, right? So how to verify it? How to do the verification? Sum of the roots is equals to alpha plus beta is equals to minus b by a. Alpha is what? Minus 1 by 3 plus beta is 3 by 2 is equals to, from here a value is 6, b value is minus 7, c value is minus 3. C value is minus 3. Minus b, minus of minus 7 upon a value is 6. Clear? Take the LCM. 3 and 2. 3 and 2 LCM. You know how to take the LCM, right? 3 and 2. I'll quickly explain the people who don't know LCM. 3 and 2 LCM. 3 ones are 3. 2. Correct? 2 ones are 2. Same. I mean 1 same. 2 ones are 2. So whatever you will be getting, 3 2s are 6 is an LCM. How to do it? See, I'll explain the LCM too. Write the LCM 6. Okay. Multiply here 3. I mean multiply here 6. Multiply here 6. Whatever the LCM. Cancel this and this. 3 1s are 3. 3 2s are 6. Minus 1 2s are 2. Minus 2. Clear? 2 1s are 2. 2 3s are 6. 3 3s are 9. This and this you need to multiply. 3 3s are 9. The students who don't know the LCM, you can learn this. Okay. Let me repeat again. Whatever the LCM you got, just multiply on the top of this 2. Then cancel. 3 1s are 3 2s are 6. 2 1s are 2 3s are 6. Then you multiply 2 1s are 2. 3 3s are 9. Done? Okay. Minus into minus plus 7 by 6. Minus into plus minus. 2 minus 9 is 7. The bigger sign is plus. Plus 7 by 6 is equals to 7 by 6. Which is LHS is equals to RHS. LHS is equals to RHS. Clear? Done. Now we'll solve the product of the roots is equals to alpha beta is equals to C by A. C by A. Or you can write that which I told you, constant term divided by coefficient of x square, correct? Now what is alpha? Minus 1 by 3 into 3 by 2 is equals to what is C? Minus 3 upon what is A? 6. Okay. 3 1s are 3, minus 3, 3 2s are 6 is equals to minus 3 by 6. Yeah. Further you can solve it by simplifying. 3 2s are 6, 3 1s are 3, 3 2s are 6, 3 1s are 3. So minus 1 by 2 is equals to minus 1 by 2. LHS is equals to RHS. Hence the relationship between these two has been satisfied. Clear? Then we'll go to the final question. Question number 4. This question, fourth question. See, this question we can't solve with the help of a splitting method, correct? Because this is not in the form of ax square plus bx plus c, correct? We got ax square, but we got bx, but we don't have the constant term, correct? So this question will be solved. let me tell this full equation, that is p of u is equals to 4u square plus 8. Okay, to get for the zeros, what we will be doing, p of u is equals to 0 and substitute. P of u is equals to 0. Okay, then the equation what it will become, 4u square plus 8u is equals to 0. Correct? In this, what I can take common out, 4 I can take common out, and u I can take common out. What is remaining? U is remaining. 4 already I took common out. U is remaining, plus 4 I took common out. 4 2 is 8. 4 2 is 8. So 2 u I took common is equals to 0. Clear? I'll equate this both. 4u is equals to 0. U plus 2 is equals to 0. U is equals to 0 by 4 is 0 by 4 is nothing but 0, and u is equals to minus 2. U is equals to, this is the two zeros I got. So what I have to verify, sum of the roots, alpha plus beta is equals to minus b by m. Okay, here in this question, a value is 4 and b value is 8 and c value is 0. C value is constant, nothing is there, 0. Clear? So alpha plus beta, this is alpha, this is beta, this is alpha and this is beta, what I have considered. So 0 plus of minus 2 is equals to 8 minus 8 upon a value is 4. Clear? Minus 2 is equals to 4 1s are 4 2s are 8 minus 2. So LHS is equals to RHS. LHS is equals to RHS. Now, so similarly, I'll verify alpha beta is equals to C by A, whereas alpha is 0 into minus anything multiplied by 0 is 0 itself. C value is 0 upon A value is 4. Correct? 0 by 4 is nothing but 0. So 0 is equals to 0. So LHS is equals to RHS. Hence, the product of root POR product of root also verified. Hope this is clear. Same way we will be solving this question also. Okay, t square minus, so what I have to write, p of u is equals to t square minus 15. P of u, t square minus 15 is equals to 0. Now, if you see this question carefully, can I write t square minus 15? Can I write this 15 as root 15 whole square? Root 15 whole square, because if I cancel square and root, I will remain with 15 only. Correct? T square minus root 15 whole square is equals to 0. Now, check this carefully. This is in the form of a plus b into a minus b is equals to a square minus b square. A square minus b square. A square minus b square. Now our b is, Here you can write here a is equals to t and b is equals to root 15. Root 15. Now this what will become? A is t minus b is root 15. T a plus b into a minus b. So this will equate to 0. So t minus root 15 is equals to 0. T minus root 15 is equals to 0. Sorry, this is plus now 1. Clear? T plus root 15 is equals to 0. T is equals to minus root 15. T is equals to plus root 15. Okay? T is equals to minus root 15. T is equals to plus root. Now, we'll verify sum of the roots and product of the roots for this question. Sum of the roots alpha plus beta is equals to minus b by a, and the product of roots is equals to alpha beta is equals to c by a. Okay. From this question, what is alpha plus beta? We know root minus 15 plus of root 15 is equals to, from this question, t square minus, we don't have t, 0 minus 15, meaning a value is t, a value is not t1, b value is 0 and c value is minus 15. Okay. Minus of b value is 0 upon a value is 1. Minus 15 plus 15 is 0. Correct? Is equals to minus 0 is nothing but 0 itself. LHS is equals to RHS. LHS is equals to RHS. Now sum of the roots is done. We'll go to product of the roots. Alpha beta is equals to c by a minus 15 minus root 15 into beta is root 15 is equals to what is c? According to us, c is minus 15 and a is 1. Minus of root 15 whole square, 15 into 15 root 15 whole square into minus 15. Square and root get cancelled. I got minus 15 is equals to minus 15, which is LHS is equals to RHS. This completes your first main of 2.2. Now quickly we'll go to exercise 2.2 second main. Okay. We'll come to the second main. When this is a quadratic polynomial, we need to find. This is what we need to find, quadratic polynomial with the help of sum of the roots and product of the roots. This is the sum of the roots. This is the product of the roots. Already they have given. This is the sum of the roots. They need to find the quadratic polynomial now. So before this, they have given a quadratic polynomial. We used to find the roots. We used to find the roots. Then we used to verify with the help of relationship between the two, between the quadratic polynomial and relation between the zeros and the quadratic, the zeros and the sum of the roots and product of the root, relation between the coefficient of the polynomial. Correct? Now they have given sum of the roots and product of the roots, wherein that is sum of the roots s is 1 by 4 and the product of the roots is equals to minus 1. Okay. So we know that formula k into x square minus sx plus p. Sx plus p. We already know that this is SOP, sum of the roots, and p is product of the roots. Correct? This is not need to write in paper. Okay, for your understanding. Okay. Sx plus p. Here in k into x square minus x value is 1 by 4 into x plus p value is minus 1. Okay. So k x square minus 1 by 4x minus 1. You can write directly also, no worries. Now taking k is equals to k is equals to 4. K is equals to 4. K value as the quadratic polynomial, the quadratic the quadratic polynomial, thus the quadratic polynomial is, what is k? We have taken 4 x square minus of, we can take the LCM as 4, okay, 1, what is x minus 1, okay. LCM, if you take 4 as an LCM, okay, if you take 4 here, multiply 4, if you take 4 multiply 4, 4 get cancelled, 4 get cancelled, I remain with what? Only x square. Here I remain with only 1, okay, that you know very well. I have taught you in a very first problem of first domain. Here this 4 and this 4 going to cancel, therefore x square minus 1. This is a required quadratic polynomial. Clear? We'll come to the second question, root 2 comma 1 by 3. Second one, root 2 comma 1 by 3. Okay. K into x square minus xx plus p. K into x square minus sum of the root is root 2 into x product of the root is 1 by 3. We're taking k as 3 now. Okay. Write it, taking k as 3. So k as 3 into x square minus root 2 into x plus 1 by 3. I'll take the LCM as 3. Okay, LCM as 3. So 3 get cancelled. X square minus root 2 x plus 1. This is a required quadratic polynomial. Next, we'll go to the next question. 1 comma 0 comma root 5. Third question. 0 comma root 5. K into x square minus sx plus p. We know that here s is equals to sum of the roots is equals to 0 and the product of roots is equals to root 5. K into x square minus 0 into x plus p value is root 5. Okay. So here the k, nothing is there. So therefore the required polynomial is x square. Just 0 multiplies nothing. We have to just remove it off as root 5. X square plus root 5. This is a required quadratic polynomial. Clear? We'll go to the next questions. Third, fourth, fifth. Further. We'll come to the next question, where is s is equals to 1 and p is equals to also 1. We know that the formula k into x square minus sx plus p, correct? So what is k? K is constant, k, x square minus sum of the root is 1 into x plus p is 1. Clear? So taking for this question also, we'll take k is equals to 1. The quadratic polynomial will be what? X square 1 x square minus x plus 1. So therefore the required quadratic polynomial is x square minus x plus 1. Clear? Just you need to conclude this. Therefore the required polynomial is this one. Okay. Here s is minus 1 by 4 and p they have given 1 by 4. Fourth question. Tell me the formula. K into x square minus sx plus p. So k into what is x square minus what is sum? Minus 1 by 4 into x plus product of the root is 1 by 4. Okay. K into x square minus into minus plus 1 by 4 into x plus 1 by 4. So taking, what will take k as? Taking k as 4. Yes, 4. 4 into x square plus 1 by 4 into x plus. We can take LCM here. We can take the LCM. 1x divided by 1 divided by 4. Okay, the LCM is 4 here. So 4 get cancelled. Therefore, the required quadratic polynomial is x square plus x plus 1. Therefore, the required quadratic polynomial is this. Last but not the least, s is 4 and p is 1. K into x square minus sx plus p. K into x square minus 4x plus 1. 4x plus 1. k taking k is equals to 1 into x square minus 4 into x plus 1. Therefore, the required quadratic polynomial is x square minus 4x plus 1. This completes your chapter. Okay, hope you like my teaching. If you have any doubts, in my explanation, so do I need to put more efforts on teaching in a simple concepts? Anything, if you have doubts, please let me know in the comment section. Please like and subscribe to the channel. Thank you.